Okay, welcome. So in this lesson, what I wanted to discuss was latitude and longitude. And latitude and longitude are essentially the ways of communicating location, position, and or position in somewhere on the Earth. So it's what you would use to understand where a certain point is. And then, say if you wanted to go from point to point, like directions, knowing one to the other. And so how this works, let's look at the diagram on the left first. Okay, so focus on this one here. I've got just a general circle here, a general view of the Earth, and I've got my latitude in blue. Latitude is also known as parallels, and I'll get to that here in a minute. And then I've got my longitude in red. So my latitude, here's blue, okay, versus red. Now my latitude, notice that the lines travel from east to west, or west to east, doesn't matter which direction, they actually can go flip-flopped. But the designation is that these are the horizontal lines, okay, if you're looking at the Earth in this type of way. That's your latitude, okay? And with latitude, the equator is going to be 0 degrees. All of these imaginary lines in the world, what we can do is we can measure them via degrees through angles. Okay, so like you're looking at various angles, and determining what those degrees may be, that's where we end up with our position on the Earth. So degrees of latitude, the equator is going to start where is going to be the beginning of, let's call it the beginning of latitude. And right here in the middle is going to be 0 degrees. Okay, so 0 degrees. So there's actually nothing there. It's like an angle going this direction here. Now with latitude, think of everything at a right angle. So if we go 0 degrees this way, okay, if you have a right angle and you go straight up, well then you've got a 90-degree angle here. Okay, so all of the various lines of latitude from the equator, and this would be in the north direction. Notice how my finger is going. Even though I said latitude measures, latitude travels east to west, the measurement of latitude is actually north to south. Okay, so if we're going from the equator to the north direction, we have in total for the northern hemisphere 90 degrees to account for the northern hemisphere. And once you reach the very tippy top, which is the North Pole, you end up at that 90-degree, what's called north latitude. And so to distinguish whether it's north or south latitude, we either put an N or an S. So let's say I was going to the south part of the Earth, which would be called the southern hemisphere, okay, this direction here. Places like South America or Africa or Australia, Antarctica, etc. Okay? It would be the exact same concept, except now the angle is flipped this way, and we would go in the south direction, so from 0 to 90 degrees south latitude. The very bottom in Antarctica being the South Pole, that would be 90 degrees south latitude. Okay. Now with longitude, the imaginary lines, they travel, and these angles travel north to south direction. And notice that they are what appear to be at kind of these circular angles, and I'll get to that here in a minute. But bear in mind that you've got north-south direction is what I'm accounting for here. But what they actually measure out in terms of positioning is east and west positions. So in this case, our longitude in red, we would be at 0 degrees here. Let's imagine this middle one here is 0 degrees, which is something called the prime meridian. Okay, instead of the equator, in longitude speak, we have the prime meridian, and I'll get to that more in a minute here. But we have 0 degrees, all right? And then from the prime meridian at 0 degrees, longitude, instead of 90 degrees in its kind of ending point, longitude goes out 180 degrees in both directions. So we measure west and east directions via longitude, 180 degrees west, 180 degrees east. And actually that 180 degree number is actually very significant, because at 180 degrees if you think about a complete circle, there's 360 degrees total, so the halfway point would be 180. So that would be the complete opposite side if I had flipped this and turned it all the way around to the opposite side. We would see, instead of the prime meridian, we would see the 180 degree line of longitude, which we call the international date line, IDL. Didn't quite make, I had the letters in my head, but the actual term itself. International date line. Okay, and I'll explain that more in the video as we get to that. But on the opposite side, 180 degrees, international date line for longitude, and on the 0 degree side would be the prime meridian. Okay, either direction, 180 degrees. Now you cannot have, let's say, 190 degrees west, because once you get past 180 degrees in this direction, everything kind of resets. Okay, and I know we're working on a flat board, but if I could show you on something three-dimensional, we would notice that it just starts to going in the other direction. So example, 180 degrees, let's say instead of we were about to hit 181, it would actually turn into 179 east. And actually we would be going in this direction here. Okay. So longitude is a little bit trickier than latitude, but it's important to understand the differences between the two and the nuances that make them unique. All right. They do work together. Okay, so they do work together in the sense of these are specific angles, and they are important to understand the exact positions. So say for example we were looking for, I'm just going to put a little mark here, Chabot College being somewhere right here. Okay, boom, like that. Okay, if Chabot College is there, and what I'm doing is completely arbitrary, by the way. In order to understand Chabot College's position on the Earth, we would need to understand its latitude first, and then its longitude. So imagine that as we're going up here, that this angle here, latitude-wise, was 37 degrees. Okay, so I put 37N, because it's north latitude. Okay, so 37, and it's in the northern hemisphere. And then imagine it's 122 degrees west. I know, again, this is kind of an arbitrary drawing I've got on this board, but just follow along with me. First thing, we have to make sure that if we were going to write this out, latitude first, comma, then longitude. It would never be the other way around. That just doesn't make sense terminology-wise. So something like a Chabot College, you could say 37 degrees north, 122 degrees west, and say you wanted to fly to over here, somewhere on the other side of the Earth. Okay. Once you were able to determine this latitude and longitude position, you can then determine how far away the distances are. So that's why all of these angles and all of these latitude longitude thing ultimately makes a lot of sense. It's for navigational purposes, for ships, for airplanes, for driving around in your car. When you log on your GPS on your car, it actually just looks at from where you are, where your phone is, to where your destination is via the address. Boom, it routes you there. That's all based on latitude and longitude. All right, now let's move on to this diagram I've got over here, and I just want to explain a couple more things in detail. So imagine here we've got the Earth again, and this time what I've done is I've rotated kind of it's on an axis. So I've got my equator at this kind of angle like this, okay? And I want to pay attention to the latitudes themselves as they are kind of curved now in this instance. What's interesting about latitude is we also refer to latitude as parallels. Okay, parallels. Anything that's a parallel line means that they never actually cross each other. So latitude lines, essentially, once you get to once you get to the very North Pole, latitude lines are just giant circles. Okay. The further you are to the 90 degree, whether on the top or the bottom, the smaller the circles get. Okay, the closer you get to the equator, the wider the circles get. But they never ever cross. Okay, latitude lines never cross. Therefore, they are also referred to as parallels. If you are asked on a quiz, parallels, the other terminology for parallels is latitude or it's longitude. Make sure you choose latitude. Okay. Now, the other example would be the red lines being my longitude. And notice that right here at the very tippy top here that I've got it turned at the North Pole, they all cross. Well, what they're actually doing is they're all converging, meaning that they're all coming together. Okay? And so by all converging, we call these lines, instead of parallels, we call these lines meridians. Okay? So longitude equals meridians. Okay? Latitude equals parallels. Okay? So they do converge at the poles, North Pole, and if we flip this around, also at the South Pole, the same exact thing happens. Other fun facts here, I've got this drawn out with some crude illustrations of land masses. But what I really wanted to highlight here, we've got Europe and Asia, Africa, Greenland, some South America, etc. Atlantic Ocean here. Your prime meridian in the dark, kind of thick red line. This is England right here. Okay, I know it's hard to tell, but that's England. And if you look this up independently, you'll get a lot more thorough information. The prime meridian, the 0-degree longitude line, the prime meridian, runs directly through what's called Greenwich, England, which is a few miles away from London. Okay, and the whole idea of longitude and England, why they're significant, is because longitude, technically longitude and latitude, both are man-made concepts. Okay, latitude is a little bit easier to recognize scientifically because we can measure angles from the sun and understand exactly what north-south position a person would be on the Earth. Longitude, not so much the same. Okay, but in order to make sense of this and in order to understand east and west, humans had to come up with this equivalent, and that's how they come up with longitude. Well, it just so happened it was the English came up with this, and then the world agreed in the 19th century. And so, lo and behold, they made the prime meridian, which would be the starting point for longitude in England. Okay? That's all for this lesson. Thanks a lot. Bye for now.